Hello, I'm Alistair Foreman and welcome back to the Aquarius Samples introductory video series. I'm here again with Max Buitendijk, the product manager for Aquarius Samples, and today we'd like to go further into our exploration of the system and look at how we can get samples data into the time series product to get some really interesting real-time insights into our data. So let's say someone just phoned in and told me there's a problem with some high nitrate loadings in the Patuxent River. We know that there's this Quilty Farms in that area, and they're notoriously dumping manure into the river and perhaps other places. Max, why don't we see if we can find out what Quilty's up to?
Thanks, Alistair. Yeah, sure. Let's go find some of this data. As usual, I'm going to use my workflow diagram to jump to observations and start drilling into my data to find the relevant locations. So I'm just going to type the Patuxent River right there, and there we go. Here's 3 locations, one of them being the Quilty Farm, and we're going to look at some ideas and locations as well to give us a bit of a better picture on what's going on. I'm going to filter for nitrate. That's what we're interested in for this example, and just quickly bring this up in a chart to see what Aquarius Samples tells me. And I think from just looking at the XY plot here and my box plot, yes, it's already quite obvious that the Quilty Farm locations has elevated and higher levels. As usual, I can just use the hover here as well to find more about these data points. But for this example, we're interested in looking at this data together with continuous data in Aquarius time series. So I will just jump over to Aquarius time series real quick. And by the way, this is a whole new platform that maybe some of you have seen, have not seen. And this is basically how continuous data is managed within the Aquarius software solution. Just a quick note, if you're interested in learning more about Aquarius time series beyond what we'll be covering today, there's an additional set of videos on our website because it's too much to cover right here. But let's just get into this example right there. So I'm already looking at the location Quilty Farms at the Patuxent River right there. We can see this is a small data set of just a few time series signals and samples data, by the way, that we need for this example. If I were to look at another demo location, this is a bit more of a realistic view where you can see lots of different time series. But for the purpose of staying with this example, everything we need for the example we have right here. So let's start with the first use case, which is making sure that my telemetry data of an observed property or parameter that I also have as lab data is of the best quality. So we can see right here, here's some nitrate coming in via telemetry from a sensor. And here I can see this is my lab data, my lab samples from Aquarius Samples that we just saw within Aquarius Samples. So all I have to do is to check these two and bring them up in my data correction tool. And what that's going to do is going to show me my continuous signal with the lab sampling data overlaid over it. So this lab data is brought in via an automatic sync. I don't have to do anything. As soon as I have this connector set up, my lab data will just be brought in automatically, which is pretty awesome to make sure that my telemetry data is of the highest quality. And we can see right here in this area, the green data is my original raw data of the sensor, and I can see it might have drifted a bit low, but I've used my lab data here, the orange little triangles, to calibrate it and bring the sensor back up to where it's supposed to be. And we can also see for my newer data, this data correction has not been made yet, but we can already see from the lab sampling data, it's quite obvious that I probably need to do some drift corrections right there to make sure my sensor readings are correct. So let's assume I've used my lab data to make sure that my sensor data is QA/QC'd in the best way. The next step then would be, here we can see I have my discharge signal right there, and I can actually combine these two in what we call a calculated derived time series, and using a simple calculation model right here, a simple load calculation that will take these two parameters as inputs, and you can see the process inputs right here. We got my discharge mean daily, and we got my nitrate values, and here's the formula that will combine these two to automatically spit out a result. And all I have to do is select this calculated derived and bring it up in my chart again. And there we go, that's my calculated daily loads. So that was the example where you want to use your lab data to QA/QC the telemetry signal you have to calculate loads of the same parameter you're interested in. But what if you don't have this parameter as a continuous signal and you want to use a surrogate, something that you know behaves very similar, and you have a linear or different regression model that you want to plug in? So I'll show you that as an example as well. For this example, we have continuous turbidity data, since that's fairly easy to measure, and we want to use this turbidity data and a regression model that we already have to combine that with our lab data. I'll show you how that works, and then combine it with discharge data to also get a continuous signal of loadings. So I'm going to open up this calculator derived, and we can see this one here is a regression using logarithmic, a regression model from turbidity. If I were to open the processing period and see the processing inputs right here, very similar to before, but now we can see here's my continuous signal for turbidity, here's my discharge, and here's the formula that basically will use the model input and the discharge to then automatically calculate my loads from there. That's how easy it is to combine discrete data and continuous data in a very, very powerful way.
Thanks, Max. I know that we've looked closely at a USGS website that does this, the National Real-Time Water Quality website. And there's lots of great examples there. They do lots of modeling of the type that we just saw. That's exactly the kind of thing that we're doing in Aquarius, which is possible with the integration between samples and time series. Thank you. That was interesting. That ends our 4th video in the Aquarius Samples series. See you next time.
See you next time.